Good afternoon to everyone. Right. So today we'll discuss limits. Okay. Yeah. Right. So we'll discuss what limits. Right. So you know some basics, but even though just I will revise and I'll go for what solving of problems. Right. So now definition of a limit of a function, correct? Limit of a function. Limit of function. Right. So that is for right epsilon greater than 0, however small, right? So there exists value L. Voice is not clear. 1 minute, but my voice is this full voice is there. Right, there exists a value L, right, such that right mod of fx minus L less than epsilon, such that 0 less than mod x minus A less than delta, where epsilon and delta are already mentioned very small, very small, right? Then L is called limit of a function. Then L is called limit of a function, right? As extending to A. As extending to A. So it is denoted by, right, limit extends to A, f of x is tends to L. Because it is not L exactly, that is why I am writing tends to L. See what is this? See, if you take right graphical method, right, suppose you take this the y equal to fx function, right? So here A plus delta, A minus delta. So this is what L, this is what L minus epsilon, and this is L plus epsilon. So as extending to A from left side, then fx is what tending to L from L minus epsilon to L, but not L. So like this. And suppose this is the value. So this is the value like this. And similarly, from right side, x is tending to A, then fx is tending to what? L, from L plus epsilon A. So like this. Then we say that this is what limit of a function, right? This is known to you, but just revising. If anyone, so generally what as fx is one values and values they are taking limits 0.1 like this, but that is this actually. That is the method is this. So as extending to A from left side, right side, then fx is tending to L from L minus epsilon, L plus epsilon. So this is what it is not exactly L, but it is tending to L. So that is what limit of function. And one more very important point is function exists in the neighborhood of A, where fx should exist, right, in the neighborhood of A, in the neighborhood of A, here. Then only this definition is holds. Okay. So as extending to A from left side, right side, and fx is tending to L from L minus epsilon to L plus epsilon, and function should exist in the neighborhood of A. Then the L is called limit of function, right? So now, one-sided limits, right? One-sided limits. One-sided limits. Let f of x be the given function. X equal A is a given point. Is a given point. And f of x is defined in A minus delta to A, right? So just I'm going like what thoda sir KP sir ने बोला थोड़ा basics revise करके we'll go for higher level, right? Okay. So A minus delta to A, and fx is tending to L minus from left of A, then L minus is called left hand limit, or you call it as LHL of fx. It is denoted by limit extends to A minus fx, and it is defined as limit extends to A minus f of x is equal limit h tends to 0 f of A minus h, where h is a very small real number. H is a very small, right? Positive real. So that means function is what tending to L minus from A minus delta to A. like this. So these are all known to you, but just I am revising. So this is what L minus. So this going like this. So here like this. Right? Function is what defined from here this. Like this. So for example, say limit extends to pi by 2 minus, right, tan x. Tan x. Simply you don't write infinity or minus like that, right? So therefore you have to find out, okay, limit extends to 0 tan of pi by 2 minus h. So limit extends to 0. This is what cot x. So this is what tends to plus infinity. So that means as extends to pi by 2 minus, this goes to plus infinity. That means if you take, suppose graph, right, pi by 2 tan x graph, if you observe, you will find out. So it is not exact value. So pi by 2 minus pi by 2, right? So this is the graph. This is pi, right? So like this is a graph. See now tending to pi by 2 from left side. This goes to plus infinity. So it is not exactly infinity, right? So that is why. So it is what plus infinity tends to plus infinity. Tends to what plus infinity, right? Now in the same way, right? So RHL. So RHL is, this is purely the friends, those who are in mains to advanced level, right? Maybe you know all this, but just I am revising, right? Let fx be the given function, right? X equal to a is the given point, is the given point, and x is tending to a from right of a, from right of a, then fx is tending to L plus, then L plus is called RHL, right? It is denoted by, limit extends to a plus fx, and it is defined as, limit extends to a plus f of x is equal to limit extends to 0 f of a plus h. So where h is, however, is very small, right? So where h is very small real number, okay? So that means, so function is defined, right, a to a plus delta. Yes. So this is what L plus. Here L plus epsilon. So therefore x values are coming like this, right? So then fx values are coming like this. Yes. Okay. Now, for example, right, so limit extends to pi by 2 plus same will take tan x, right? So this is a not infinity again, don't substitute. So limit extends to pi by 2 plus tan x is equal to limit extends to 0 tan of pi by 2 plus h. So limit extends to 0 minus part h. So it is what tends to minus infinity. Tends to minus infinity. So if you observe, same like graph, right? 0, pi by 2, pi, right? So here it is, the graph is like this. See, now values tending to right side. It goes to what? Minus infinity, but not minus infinity. So tends to minus infinity, right? No. So next, existence of the limit. Existence of the limit. So number one, let f of x, right, be the given function. F of x be the given function x equal to a is the given point, right? Is the given point. If LHL is equal to RHL, right? Then fx has limit exist as extends to a. If LHL is not equal to RHL, then fx has limit does not exist, right? Limit does not exist. And other case is this. So let f of x, right, with a given function x equal a is the given point, if fx does not exist in the neighborhood of a, then fx has limit does not exist. Limit does not exist. So two cases may limit does not exist. One is that LHL, RHL are not same, limit does not exist. And another case is this. For example, right? For example, limit extends to 0, say x factorial, right? So it's not 1, right? It's not 1. So therefore, in the neighborhood of 0, x factorial is not exist. In the neighborhood of 0, the function exists. So therefore, limit does not exist in this case. Now, in the same way, in our example, limit extends to pi by 2 tan x. Limit does not exist because LHL, RHL not exist, right? Not same. That is what one is infinity and minus infinity. Now, in the same way, if you take this, say, limit tends to 0, right? 1 plus 2 plus so on plus n, right? By 10n. So these are same case. So limit n tends to 0, n into n plus 1 by 20n. N will go, limit n tends to 0, n plus 1 by 20. Right. So it does not exist. Does not exist. Since, right, in the neighborhood of 0, right, in the neighborhood of 0, the function n plus 1 by 20 does not exist. Right. Because domain is what? Natural number, no? N plus 1 by 20 exists for natural numbers. But in the neighborhood of 0, there is no natural number. So in that case also, limit does not exist. So these are the two cases for limit does not exist. Right. So next, right. Now, the next one is this. Maclaurin series. Right? Maclaurin's series. Maclaurin series. So let f of x be the given function. Right? F of 0, f dash 0, f double dash 0, and so on existed. Then, right? Because in many places we'll use a series. So why that series came? Because this is the reason, right? Then f of x is equal to, right, f of 0 plus x by 1 factorial into, right, f dash 0, x square by 2 factorial f double dash 0, x cube by 3 factorial f triple dash 0, and so on infinite terms. So what is the reason for this? This is the reason, right? So let f of x you consider like this: some a naught constant plus a1x, right, plus a2x square plus a3x cube, and so on infinite terms, where a is or real, where a is or real, right? Now, therefore, I will write f of 0, obviously a naught. Now, f dash x, so a1 plus 2a2x plus 3a3x square plus so on infinite terms, right? So again, I'll put a 0, a1, right? Now I will take another time derivative. So 2 into a2 into 1, 3 into a3 into 2x, right? Plus so on infinite terms. Again, I will write f double dash 0. a2 into 1 into 2, I will write 2 factorial. So a2 will be f double dash 0 by 2 factorial, and so on. You can write an is f of nth derivative, right, 0 by n factorial. So put all this in the fx. We call it as 1. So put in 1. Put in 1. So what we get? Therefore, fx equal to a naught f of 0. Right? Therefore, f of x equal to a naught f of 0, a1x into f dash 0. Say 1 factorial, right? and x square f double dash 0 by 2 factorial like this, and f triple dash 0 and so on, infinite terms, right? Infinite terms. So by using this now we can write a standard series that will use in the what problems. Okay, that we'll see now. The expansions, standard expansions will do. Right. Take them. So now the first one is Kumaraswamy garu joined. Right. Standard expansions. Standard expansions. So one, right? Expansion of e power x. So let f of x is e power x. So f of 0, 1, f dash x e power x, f dash 0, 1, all 1 only, right? E power x, f double dash 0, 1, and so on. Right, minimum 3 values are required to find what any x series, right? So now we have to substitute this what in the Maclaurin series, right? Put in MS. Therefore, e power x 1 plus x by 1 factorial into 1 this only. X square by 2 factorial into 1 and x cube by 3 factorial into 1 and so on. So therefore, this is the reason of e power x, right? X square by 2 factorial, right? X power n by n factorial, infinite terms. And in the same way, replace x by minus x on both sides, you will get e power minus x. Alternative, right? And so on, plus minus, infinite terms, right? So this is what e power x, right? So now, if you take the second is, right, log 1 plus x, right? So I don't know, you are telling sarcastically, right? Really, I don't know. Okay, no problem. But see, this class is what to groom like from like mains teacher to advanced level teacher. So that's why I'm going from 0 to like this, right? No problem. Right. Next. Okay, expansion of log. We will do this a power x because it's application only a power x, right? So our fx is what a power x. This we can write e power log a power x because any function you can write e power log of x. Of course, the base is e, right? But this logarithm application, this. Okay. So now here f of x is what? E power x log a. Now in this e power x may put x log a. That is 1 plus x log a by 1 factorial. X log a whole square by 2 factorial. And so on, infinite terms. So this is what a power x expansion, right? X log a by 1 factorial square log a square by 2 factorial and so on. infinite terms. Right. Now we'll see the other expansion, right? Expansion of log of 1 plus x. Log of 1 plus x. Let f of x is log of 1 plus x. Implies f of 0 is 0. Because log 1. F dash x is 1 plus x power minus 1. So f dash 0 is 1. F double dash x is minus 1 plus x power minus 2. So f double dash 0 is minus 1. F triple dash x. So minimum 3 values required. Then we can f triple dash 0 is 2 and so on. Okay, 3 values we got. We'll put in the MS. Right? We'll put in the MS. Right. So therefore, now log 1 plus x expansion is right. Therefore, fx equal to log 1 plus x is f of 0 is 0. Right. Then f dash 0 is what? Minus 1. That is plus 1. Right. So a minute, I'll check it. Okay. But this is here. Not here. Right. Okay. So therefore, f of 0 is there. F dash 0 is what? Minus 1. That is plus 1. So x by 1 factorial 1. Correct? So 1. Right. So minus that is x squared by 2 factorial into what is f dash 0 plus 2. Where is that values? Wait a minute. Yes. So gone, deleted. Right? Okay. Right. Fx is right log 1 plus x. F of 0 is 0. F dash x is 1 plus x power minus 1. So f dash 0 is 1. F double dash x is minus 1 plus x power minus 2. So f double dash 0 is minus 1. F triple dash x is 2 times power minus 3. F triple dash 0 is 2 and so on. Okay, so put in MS, that is fx log 1 plus x, f of 0 0. So 0 plus x into 1 f dash plus x squared by 2 factorial into minus 1 plus x cubed by 3 factorial into 2. Right, like this, infinite terms. So therefore log 1 plus x is x minus x squared by 2, 6 over 2, 3, like this, and minus, right, plus like that. So this is a log 1 plus x. Similarly, replace x by minus x. So minus x squared by 2, minus x cubed by 3, all this. This is not factorial. Okay. And all minus. Right. This is a log 1 plus x. Right. So now we'll see what sin x, cos x, tan x. These are very useful. Right. That way we'll do. So now we're going for what sin x. Right. Expansion of right sin x. So let fx is equal to sin x. So f dash f of 0 0. F double dash is f dash is cos. This is a 1. So we got one value. So minimum 3 values चाहिए. So अभी minus sin x. अभी ये 0 हो जाएगा. Right? F triple dash x is minus cos x. F triple dash 0 is minus 1. Fourth derivative, sin x, 0. Now last will get, right? Fifth derivative, x is cos x. So this is 1, right? Now therefore put in MS. Maclaurin series, therefore sin x is equal to first 0, x into 1 factorial, and x square by 2 factorial 0, cube is there, minus 1. मतलब odd alternate signs. 4 0, right? And x power 5 by 5 factorial minus 1, infinite terms. So therefore, this is the reason for sin x, x by 1 factorial minus x cube by 3 factorial, x power 5 by 5 factorial minus x power 7 by 7 factorial. Like generally, teachers just write the expansion doing. Sometimes I face many students. So what is the reason for this? Okay, while teaching, main students now they listen, but when come to the advanced students, and he will ask what is the reason. Simply, if you write the formula, they will not accept. So I faced like many students. So that is why you should not face. That is why I'm explaining reason, right? So this is what sin x. Now we'll go for cos x, right? Expansion of cos x. Expansion of cos x. Right. So if you take fx is cos x, right? F of 0 is 1. F dash x is minus sin x 0. F dash 0 0. F double dash x minus cos x. F double dash 0 is right minus 1. Minus 1. F triple dash x. This is what sin x. So this is 0. Now we get Taylor's theorem. Through Taylor's theorem only you got now this. Okay, Taylor's theorem H0, then Maclaurin's. Okay, sir. So Taylor's theorem application, but these people want what G level में sin, cos and all this. So that is why Taylor's में H0 लिया मैं. This we got. So that's why I proved Maclaurin series, then doing. Okay, if you want to do that no problem. That's why this, what I am telling for purely the friends, those who are coming from mains, right? This class is for that friends only, not like known people, right? So cos x is 1. First one is 0. Second is minus. Third 0. मतलब even powers, even powers, alternate signs, right? So this is 1, right? So cos x 1 minus x square by 2 factorial plus x power 4 by 5 minus x power 6 by 6 factorial plus 1. Yes, this is. Now we will do what tan x. Right, this is enough. Then after that we do some questions. Okay. Check. Now tan. So mostly we're using this right? So expansion of tan x. So here also we want three values, right? Minimum three values. X is equal to tan x. First value 0, right? F dash x is secant square 1. F dash 0 1. Okay, two more values required. F double dash x 2 secant x square tan x is also 0, right? Now third is 2 secant power 4x plus, right? 4 secant x tan x. So this becomes what? 2. This is 2. One more value required, right? Fourth there. 8 secant square x tan x, right? 4 secant power 4x plus 8 secant square x, right? Tan square x. Because secant square derivative 2 secant x tan x. So here we'll get what is that? 4. Enough. Okay, substitute in that. Therefore, tan x here first one 0, second is x, second 0, third means 2 by 3 factor 6 means 3 x cube by 3 4 0. 4 is not 0, that is right. 4 is 8 secant cube x, right? This is 0. Then here 4 this is also 0 actually, because tan derivative secant square, right? Tan derivative secant square. 8 secant square tan square x. This is 0, right? So 8 secant square x tan x, and this is what 4, right? This is what third derivative is what 2 secant square secant power 4 plus 4 secant x tan x secant x tan x. So this is tan square x. Yes, tan square x, because first derivative is what 2 into secant square tan secant power 4 plus 4 secant x tan x. Okay, here it is. Okay, this is correct only, but fourth derivative 8 secant cube x, this is correct, plus 4 secant square x, here also it becomes 0. It is not 4, sorry, right? We'll do this. 4 secant square x, 4, this is what 2 tan x, right? This is what 4, 8. This is what 8. This is 8 secant x. Again, secant x tan x. Secant square tan cube x plus 8, right? Secant square x tan x secant power 4x. 0. This is a 4 0, right? Okay. So like fifth derivative, fourth derivative 0, fifth you will get right here only. This is secant square 8. Remaining all 0. Right. So 8 secant power 4 is 8. So that is what x power 5 by 5 factorial into 8 plus so on infinite terms. So what is this? Tan x is x plus x cube by 3 plus 120. Correct? So what you will get, that is secant square 8. 120. That is 2 by 15 x power 5. So this is the what tan x. Right. So these are the what expansions. Right. So now, okay, for example, based on this application, so limit extends to 0, sin x minus x cube by what is that, x cube, right? So we can do this by what hospital also. Wait, phone came. Right. Right. So hospital also series. Right. So if you use series, right? So this is what x minus x cube by 3 factorial, x power 5 by 5 factorial, and so on. Minus plus. So minus x cube by, sorry, minus x. This is also x. Okay. So by x cube. So x cancel. X cube no. So minus 1 by 6. Because upper x cube, here x cube, coefficient minus 1 by 3. Minus 1 by 3. Right. So, for example, if limit extends to 0, cos 4x, a cos 2x plus b whole by x power 4 is c. Then a, b, c. The question bracket c not equal to 0. C not equal to 0. So this also we can do by L hospital also, and series easy hota hai, right? So limit extends to 0, cos 4x 1 plus, right, 4x by 1 factorial, right, minus alternate signs, okay, plus 16x square by 2 factorial. So denominator x power 4 no, you should write x power 4 the numerator mein, right? 4x power 4. So 256 x power 4 by 4 factorial minus plus so on, and plus a times. So 1 minus 4x square by 2 factorial, and plus that is 2x power 4, 16x power 4 by 4 factorial, and plus so on. Then plus b whole by x power 4 is c. So that means here finite value should come, means denominator x power 4, numerator must be x power 4. Before coefficient must be 0. Matlab constant term 0, x coefficient 0, x square coefficient 0, x cube coefficient 0, all 0. So therefore, so constant must be 0. What is that constant? 1 plus a plus b is equal to 0. So a plus b equal minus 1, one equation. Now coefficient of x 0, coefficient of x. Okay. So coefficient of x is what here? Right. This is a cos 4x. No. This is x square. X square is x power 4. Square is not a, right? No. Minus 4x square by 2 factorial. This term is not there. Okay. Right. This is constant term. Then what about coefficient of x square? X not there. Coefficient of x square 0. What is that? Minus 8a. Right? This is what minus 8a. Right? Minus 8a here plus minus 2b. Minus 2a. Right? Minus 8. This is 8. So you will get A is -4. A -4 put here. B is equal to 3. Yes. Now we got AB. Now x power 4 must be C. Coefficient of x power 4 is C. That is what limit. Because denominator x power 4, no, numerator must be x power 4. Then it is C. Right? So coefficient of x power 4 is C. Coefficient of x power 4 is C. What is that? We'll see. Right? Coefficient of x power 4 is C. Now we collect coefficient x power 4. 256 by 4 factorial. Right? 256 by 24. Right? And here 16a by 4 factorial. Right? 16a by 4 factorial is equal to C. Right? You know A value, substitute, you get C value. So this way you can write. This is the use of series. Right? So these are much 8 32 8 threes. This is 16 24. 8 twos are 8 threes are is equal to C. But C A value, you know, -4. So 32 minus 8 by 3 is C. So which is 8. So these are the values of ABC. So this way we can write. Or you can use L'Hospital rule also, but like 4 times it apply. Because x power 4, no, the denominator, right? Now, suppose if limit extends to 0, cos square x minus cos x minus e power x cos x plus e power x minus x cubed by 2 whole by x power n is a finite value. Finite value. Bracket not equal to 0. Then the integral value of n is. Then the integral value of n. Shall we try based on this only? Not getting. Say limit extends to 0, right? So instead of using direct expansion, थोड़ा simplify करो. First two terms cos x common, no? Cos x minus 1. Third, fourth, what is common? E power x common. So minus e power x into cos x minus 1. ये थोड़ा simplification easy होता है. Is x power n is equal to say k constant, right? Limit extends to 0, right? Cos x minus 1 into cos x minus e power x minus x cube by 2 by x power n, right, is equal to k. Now you write the what expansion extends to 0. Cos expansion, you know now 1 minus x square by 2 factorial, x power 4 by 4 factorial, x power 6 by 6, and so on. Okay, right. And here same. Okay, you take this square bracket, 1 minus x square by 2 factorial, x power 4 by 4 factorial, x power 6 by 6 factorial, plus so on, minus 1 plus x by 1 factorial e power x series, all to x power 3, x power 4 by 4 factorial, and so on. Okay, enough. Right, minus x cube by 2 already is there. Whole by x power n is k. Right, here 1 will go, 1 cancel hota hai. Right, now here also 1 is there, no? Here also 1 is there. So this one also cancel. This one also cancel. Cos x minus 2. Right? So first we'll simplify this second bracket. Right? Extends to 0. Minus x square by 2 factorial, x power 4 by 4 factorial minus O(n) of 4. Right? Here, what is the highest, least minus x, second bracket, this minus x. Then minus x square by 2 factorial minus x square by 2 factorial is minus x square. Then cube terms, no, cube term is there here. E power x min, x cube by 3 factorial. X power 4 either is there, either is there. So minus x power 4 by what x power 4 will cancel hota hai, right? X power 4 either cancel. Then x power what will get? 5 will get. X power 5 will get, right? X power 5 by 5 enough. Okay, whole by x power n is equal to k, right? Now, of course, minus x cube by 2 is also there. Okay, minus x cube by 2. Minus x cube by 2 is equal to k. See, here, this cancel hota hai. Minus x cube by 2, here x cube by 2 cancel hota hai. See, this term into this term cancel. Right? So, what is the highest, least power? X power 4. X power 4. So, x power 4 by, okay, limit extends to 0, x power 4, and so on higher powers by x power n k. That means n must be 4. N must be 4. N must be 4. So that is a what integral value of n. For n is 4, the limit is constant. And what is the k value? They may ask k value also. What is the x power 4 coefficient here? X power 4 coefficient, you will get 2 cases. Right? I will write that. K is equal to x power 4 coefficient, no? X power 4 coefficient, this one, that is plus 1 by 2. And any other case, you will get x power 4, no, in this constant, that's 1 by 2. No other case you will get x power 4. So this way they ask, right, the value of n and the limit value. Okay. Check. Next concept we'll discuss. We'll go into that, right? Yeah. So we'll discuss what Hell Hospital rule we'll discuss. That standard limits, you know, no? Right? Sin x by x, tan x by x. If you apply all the series, you'll get it that, right? So now, right, limit extends to a f of x by g of x, right, is 0 by 0 form. That is f of a 0 and g of a 0. Okay. So therefore, this what we can write, limit extends to a fx by g of x is equal to limit extends to a fx minus fa, we can write, and gx minus g of a, because f of a anyway 0, right? So this what I'll do is limit extends to a fx minus fa by x minus a and by gx minus g of a by x minus a. So the numerator is what? That is f dash a. That is f dash x at a. And this is g dash. Right. So now what you will gain this, if you apply this is also, if it is right, again, right, 0 by 0, then, so this is the reason for L-Hospital limit extends to a f dash x by g dash x. This is what 0 by 0, right? So therefore, this is equal to limit extends to a f dash x minus f dash a, because f dash is 0 here, by x minus a. Same like that. You have to continue. So extends to a g dash x minus g dash a by x minus a. This is what f double dash a and g double dash. Again, suppose if it's 0 by 0, I have to continue. So continue like this, right, till getting finite value. So this is the reason for L-Hospital. Now we'll see, right, Cauchy's, right, first principle on limits, right, Cauchy's first principle on limits. What is it? Maybe you know this. Cauchy's first principle on limits. That is what this limit extends to a fx power gx, right, is a 1 power infinity form, where limit extends to a, right, fx is tends to 1, limit extends to a gx is tends to infinity, right? Now, in that case, then limit extends to a fx power gx. This is equal to what we can write, add 1, subtract 1. Add 1, subtract 1. and power gx, right? Why we are adding only one, you may ask. So you know now from basics, limit extends to 0, 1 plus x power 1 by x is e. For this purpose, I added 1. Okay. So 1 plus fx minus 1, right, power. Okay. So I will divide by fx minus 1 and multiplied by fx minus 1 into gx. Okay. You call it as a 1. So now I will take put fx minus 1 is equal to say y. Okay, so if you take limit extends to a fx, right, minus 1 is equal to limit extends to a y. But limit extends to a, oh, this is 1 here. So this is 1 minus 1, that is y tends to 0. Okay, y tends to 0. Now 1 becomes what? 1 implies, right, limit extends to a is y tends to 0, 1 plus y, power 1 by y, right? And here we are not changing. That is limit extends to a, what is that? Fx minus 1 into gx. Yes, but this is what e, no? E. For limit extends to a fx minus 1 into gx. So this is what Cauchy's first principle. Cauchy's first principle limit, right? Yes. Friends, please don't leave because some disturbance came. So rejoined. Sorry for the interruption. The middle, something happened. You're disconnected. Right. Right. Limit extends to a fx power gx 1 power infinity that we had kept. So, for example, right, limit extends to 0. Right, sin x by x whole power 1 by x square. Right. So this is obviously 1 power infinity form only, correct? So simply you write limit extends to 0, right? Sin x by x minus 1 power x square fx gx. So fx minus 1 gx, right? So limit extends to 0, sin x minus x by x cube. Right? This we did know already. I think 1 by 6, right? So, or otherwise you can apply L'Hospital rule minus 1 by 6, correct? 3x square. So, limit extends to 0 minus sin x by 6x, right? So, this is 1. So, e power minus 1 by 6. E power minus 1 by 6. Say, for example, limit extends to 0, right? Like 1 power x, 2 power x, 3 power x, from 20, 22 power x by 2022 whole power 1 by x. Yeah, this is also 1 power infinity form, right? 1 power infinity form. Say 1 power infinity form. So e power what limit extends 0, 1 power x, 2 power x, 3 power x, 2022 power x, right, minus 2022 whole by 2022 into gx is 1 by x. Now you got 0 by 0, right? Apply LH rule, right? Limit extends 0. 1 power x log 1, 0. 2 power x log 2. 3 power x log 3. And so on, right? 2022 power x log 2022 by 2022 into x derivative 1. What is this? Log of 1 into 2 into so on 2022 by 2022. So e power 1 by 2022 log 2022 factorial. So it goes this. So 2022 factorial power, right? 2022 factorial power 1 by 2022. Or we can write this 2022 at root of 2022 factorial, like this also, right? Now we'll see that what Cauchy's second principle. Is that Cauchy's second principle on limits? Okay, this mainly advanced part like this Cauchy's first principle, second principle, right? M greater than G amount. Here, maybe because x tends to 0 over 1 by x. But m greater than gm, you will apply for base, then apply what power? How you apply m greater than gm? Okay, you can apply m gm between 1 power x, 2 power x, 3 power x, so on 20 power x, right, by 2022. Then raise 1 by x. Yeah, you can. Then take limits. Yeah. Okay. Right. But see, from my side, clear, because I am working under a host, but I am not giving this. But from my side, it's good, right? Voice is not clear. Voice is okay. Nobody. Okay. Voice is okay. But screen is not coming. Okay. But from my side, there is no problem. What happened? Okay. Let's see. Now, clear? Ready? Okay. Right. Right. Okay. Take. Take it down. So, this is what is second principle. What is second principle on limits? On limits. This is just by observation only, right? So limit n tends to infinity, right? Un power 1 by n, where un is function of n, is equal to limit n tends to infinity un plus 1 by un. So this is called right, Cauchy's second principle on limits. This, where un is function of n, where un is a function of n, right? Just you have to use this only, right? This is by what induction you did, Cauchy proof. Okay, just for our G level, that much proof, convergent, divergent, he was used. Just we can use this, right? Now, suppose, for example, say what will take limit n tends to infinity 2n cn whole power 1 by n. This is the question, right? Limit n tends to infinity 2n cn power 1 by n. So this is what function of n, obviously base. So this is equal to limit n tends to infinity 2n cn power 1 by n is equal to limit n tends to infinity, right? Un plus 1, 2n plus 2, what is that? Cn plus 1 by 2n cn, right? So this is what limit n tends to infinity 2n plus 2 factorial by n plus 1 factorial into n plus 1 factorial, right? Now here 2n factorial n factorial n factorial, right? So limit n tends to infinity 2n plus 2 into 2n plus 1 into 2n factorial by n plus 1 into n factorial, n plus 1 into n factorial, n factorial by 2n factorial, right? So 2n factorial cancel, n factorial cancel, n plus 1 n factorial cancel. So what we got this? We got this limit n tends to infinity, right? So 4n square, okay, and so on by niche n square and so on. So 4 is the what limit? 4 is the limit. Okay. So in the same way we can use this also. You try this limit n tends to infinity n factorial n power n power 1 by n. Try this. Limit n tends to infinity n factorial upon n power n. Yes, Vishwanath sir, got it. हाँ भैया ఎక్కడ ఉంది ఇక్కడే ఉన్నా బయట బయట ఉంది నేను బయట ఉన్నా రాలే రాలే నేను ఒక 5 నిమిషాలు తర్వాత చేస్తాను మేడం. Limit of a sum. No, not required. Limit of a sum. Use this now. Vishnu sir. So limit n tends to infinity. What is this? N plus 1 factorial. Right now? N plus 1 power n plus 1 into n factorial power n power n. Okay, un plus 1 by un. So, of course, limit of a sum there will do in integration. Different n factorial, n power n by n factorial. And here, n plus 1 power n into n plus 1. Right? N factor will go. And n plus 1 will go. Right? So, what we get is limit n tends to infinity n power n by n plus 1 power n. What is this? Limit n tends to infinity 1 by 1 plus 1 by n power n. But this is e, no? So 1 by e. Because limit extends to infinity 1 plus 1 by x power x. That is what e. So it is what 1 by e. Okay. Right, okay. We'll stop here.